Hi everybody, welcome back. Third video in today's series. We want to work with the properties of logarithms, the laws of logarithms. And this time we're going to work from the expanded form, which means we're adding and subtracting and having the number out in front. And we're going to move back to this condensed form where we're multiplying and dividing. Okay, so backwards of what we did in the last video. Pretty quick. First thing we want to do is we want to go ahead and we want to take any exponent. So that's a number that's out in the front, right? And we want to go ahead and jump it back into the first value. So I'm going to have log base 2 of 5 plus log base 2 of 4 squared. So I just simply took the 2 and I moved it back. That's the first step, is to work with the exponents. Second step, because I see that there's a plus sign here, I want the log base 2 of, and plus means multiplication, 5 times 4 squared. And then from here, I think you could probably evaluate that on your own. It's log base 2 of 4 squared is 16, and 16 times 5 is 80. So it's log base 2 of 80, and that would be the format of my answer. So I'm working from multiple logarithms back down to 1. Okay, what if I get 3 values together? So you'll notice then that I have the natural log of a. I'm going to go ahead and do this in one step. See that 2 out in front? I'm going to move it back up here and call it b squared. Okay, so I have natural log of a, but I'm subtracting a b squared, which means I need to rewrite it as a division. I'm going to divide by b squared. I'm also, because this is negative, I'm also dividing by c. So the c needs to go on the bottom. And I end up with the natural log of a over b squared times c. Okay, a little bit more complicated, but really the same idea. Ready? This doesn't have a base, so it's assumed to be base 10. Remember, that's just a reminder from last time, but I don't need to write it, okay? It's assumed to be a 10. I have a 12x that's on top. I have an x minus 1 that I'm going to multiply by that's on top, and I'm going to divide by a 4x. Now, that would be fine, except really we can simplify this, right? And I see that I have a 12 times an x minus 1 on top. The 12 and the 4 can reduce to 3 over 1. And the x's would go away completely. So I'm really left with then the log of 3 times the quantity x minus 1 all over 1. And if that's the case, then why would I even write the 1 on the bottom? It's really the log of 3 times x minus 1. You could leave your answer like that if you want to. Probably preferable to do this. Distribute out the 3, and you get the log of 3x minus 3. So that would be the format of this answer. Okay, a little bit of work there. So in other words, when we get division, make sure that you're looking for simplification if all possible. And the last one I just threw in here just because it involves just a bunch of different letters. There's really nothing more confusing about it, okay? First step I would do is I would see this c here, and I'm going to raise d to the c power. I'm going to take the r here out in front. I'm going to raise it to the r power, okay? So I have log base a. Notice they're all log base a. That's important. Of. b is positive, so it goes on the top of the fraction. d to the c power is on a negative number, so it's going to go on the bottom. And s to the r power is positive, so it's going to go on top. And so your answer would be log base a of b times s to the r power divided by d to the c power. So hopefully that's pretty straightforward. You see the patterns, right? We're just getting used to these patterns of how can we rearrange those 3 big rules, okay? That's the last thing we're going to do with condensing and expanding today. The last one is the real nice rule. It's called the change of base formula, and we finally get to learn how to evaluate log base 2 of 30. What power do I need to raise 2 to in order to get 30? And this will be a game changer for how we solve for x.